Well, greetings Webbers. Today is all about cookies. Managing cookies, how to set up a basic cookie and use it to keep track of user data and to keep each user separate. To do this, I'm going to continue working with the Unique Candlestick Game I've been working on for a while now. Currently, it only takes one user at a time, which is pretty bad for a web-facing program. But today, all that changes. Cookies are something the web has been used to for some time. Basically, they are a small piece of information stored on the user's computer, traditionally in a text file. The easiest way to use them is as a unique identifier. When a user first arrives at our site, we make up a cookie, put it together, and we'll put a unique string in that and send it with the header of our web page we send back to them. After that, when they come back to our site, at least before the cookie expires, they can send the cookie back and tell us who they are. And the browser normally does this without telling them, so we can find all of the information we have stored next to them. And after that, when they come back to our site, they send the cookie back to us, and that lets us know who they are, and we can find all the information about them and give them appropriate responses. There are three important functions we're going to need to use to do this today. First, we're going to need a cookie constructor, which is actually, we're just going to make it as a struct. Secondly, we're going to need to use http.setCookie, which takes a response writer. We happen to have a response writer from our handler and a cookie, which we will have just made. And the last function is http.request.cookie. This is a function that belongs to the request, which we get in our handler function. And we can just pull the cookie out of that by its name, because every cookie has a name, so you can actually send like 5 or 6 cookies and get them back all with different names and different stuff, but all we need is one. So we'll just take the one that has then their unique identifier on and find their place in our stuff, and that's all we need. So let's get to it, shall we? So here we are. I have here the global variable game, which we no longer want to have, so I'm just going to delete it and let that go. We need instead a struct, which will be what's going to be stored for each user's session. So we'll call it user session, and this will be a struct. And inside this struct, we're going to need, at the very least, we're going to need a game, which I'll call G, to pointer to types.game, and we're going to need a time, and we'll call that last used, and that will be a time.time. Okay, so that's our two important pieces of data we need here, and then we'll have a variable called sessions, sessions, and that is a map of string to user. Do we do that as a pointer? No, I'm not going to do that as a pointer. I'm just going to call it user session. Clearly the game is a pointer anyway. And now in our handle func, no, we need our main function. We need to make this map of sessions, don't we? So that's where we set up the templates. Let's put some comments on that to make that slightly easier to read. So template builder, and then down. So up here we'll have another thing, which is our session builder, and I imagine there's going to be a few things we're going to need here, but at the very least, sessions equals make map from string to user session. I don't know exactly what else we're going to need for that right now, because the handler is mostly going to have to deal with this to get a game. So the first time someone comes here, we're going to check if they have a cookie, right? So let's see if we can get a cookie. C comma colon equals r, that's our request, dot, and what was that function called? Now we clearly know we're not going to get a cookie yet because we've not sent any cookies, but let's do it. http.request, and it's just cookie. Okay. Cookie. And we give it a name, and this cookie will be UID. Just because that's basically what I'm going to use it for. And this will either return a cookie or it will return an error. If we have a cookie, if error is not equal nil, then we don't have any cookie, we don't have any user. We're going to need to make a new game, a new user. Otherwise we'll just use the game, we'll find the game in the thing. So if the error is not equal nil, that means we have an error. Then we need to make a cookie. So C colon, no, not colon equals anymore. C equals and http.cookie, and that's a struct. And the things we need for a cookie, well, let's take a quick peek at the struct definition, shall we? Here it is. So cookie has a name and a value. This is like a key value pair, basically. So you use this when you get sent a lot of net cookies. The name is how you're going to sort which one is the one that matters to you. Well, I've called that UID when I was searching for it, didn't I? So I'll have to call it that. And then we need to give it a value. And the other useful thing is probably to give it an expiry time. Now, I don't really want people using the same cookie for terribly long, so I'm going to set that relatively short. We use time.addDate, I think is probably the best way to handle that. And we'll just add it to now. So http.set.cookie name, and that is UID. And then we need to give them their unique identifier. Well, how are we going to get a nice unique identifier for them? Let's just make something up here. So this is value, and so fumpt.sprint printf, and we're just going to make a string which has something akin to what I'm looking for. %d colon %d. So I'm going to use two numbers to make sure it's quite unique. The first one I'm going to send is basically time.now. Time.now.unix. And the other thing we're going to take is rand.int n. And why not just make it to 10,000? I feel like this means we're going to have a pretty secure. No one's going to have the same number, because you've got to. Even if we got the same random number, they couldn't get the same random number at the same time. Now I have not closed a few brackets here. There we go. And we do have one other thing which we need, which is expires. And we'll set expires to time.now. And we'll give them a day. Well, I think if you don't set an expiry date, most browsers just take it as when you close the browser. Expires time.now .add, and you could just add time. Aha, we have some constants here. We have everything up to an hour in duration. So we'll have to just do 20. So time dot hour times. That'll give them a day. Oh, and at this point now we close the squiggly. And now we've made a cookie, in theory. So we've either got the cookie from here, or we've got the cookie from here. Now we will grab them from the map. Now again, I'm not doing concurrency checks right now. Concurrency checks are important. User s colon comma OK colon equals. So it's our map, which is called sessions at c dot value. If okay, then we have a live game. We have something we're working. Actually, let's do it the other way around. If not okay, then we can make our session, can't we? Then sessions at c dot value and we can make a new thing here, can't we? New game types dot here's our function new game, just takes the number of players. Types dot new game, and we'll just keep working with 5. So that creates us a new game, but that's not what we want here. What am I doing with a map on the left? Right. So here we've made a new game, but that's not what that session is. We actually need a user session. User session, and it's just a map. And the other thing this needs is a last used, which is going to be time dot now. I guess it makes sense here. Ooh, and now I know why it needs to be a pointer. Okay, user session is now, this is now a map of pointers. So, and the reason for that is because when I now, I'm going to have a user session here. User s colon equals, and I'm going to put this all in. What have I done now? Oh, because I took that off. User s. So now we have our session. Either we've found the session that fits, or we have made a new session. So now we can grab a game. In fact, I might even here at this point say game colon equals user s dot g, and that g will be our game object. So now we've got a game object. That means I hardly need to change anything here, because the game we're working with now is just the local game. We can run all of this. The only other thing I need is to use https.setCookie before I try and do any writing. So where do I actually do any writing? Here's where I execute the template. Let's print out. No, that's fine. I'm pretty sure the entirety happens in template. So but before we do the template, and it's important it happens before the template, because you have to write the header before you write the bottom. There's some data reasons why that has to happen. We will call http.setCookie and we send it W, and we send it C, which is our cookie. I actually feel like we've basically got everything needed for this to work, except that it won't be concurrent. So we'll deal with the concurrent handling in a minute. Let's just try and run it and see if everything works. So go run. This is going to have some errors, of course. It wouldn't be programming if you didn't get a few. So undefined game. Candlestick Go 95. Oh! So this is in our main function where I create a new game, but that's no longer needed because we're using our sessions instead to create new games with the sessions. Sessions declared and never used. What? I never used them? Did I put a colon equals somewhere? Bad habits. There we go. It's a good thing that Golang is really good at type checking and responding. Cannot use make map string user session as type map string. Yeah. And of course I changed whether this was a pointer at some point, so there we go, fix that. I'm getting rather whoa! That started a little bit too quickly for me to be happy. I expected more errors. Alright, let's do this then. Control T, local host, colon, I think it was 8081 I put this on. Here we go. So far, Candlestick, please choose a card. This is working. We have a game. If I click on 3. So far, things have progressed. Clearly player 1 won the last round and everything is still happy. I've still got the same game, which is an important part. So look, 3, 13, 10, 1, 1. So if I click on this again, yeah, we still got the same game. Now let's open up another browser. And we'll do the same in here. Alt D, local host, colon 8081. Go here. We've got a different set of cards. If I click on here, I've got this. And on this one, player 0. Oh, I won it. I won it because 8 was there, so that made it the lowest game. So I get to choose my card first. And if I come over here and push a button, have we had any problems, any collisions? No. So these two players, completely separate, have their own separate thing. Let's so we have two separate programs running. Now, the challenge is, the small thing that I haven't covered is, of course, that maps are not thread safe. So if two people are using this, these will be running in two separate Go routines on. Every time I make a call and another one makes a call, they will go on separate Go routines. And if two of these Go routines try to access the map at the same time, the map of sessions, there will be a problem. So, I don't want that problem. I'm going to just, at least for this time, I'm going to stick a mutex around the map, and we'll look at channels next week and some of the other options about how to make multiple users or multiple Go routines thread safe. But for now, a mutex seems to be the sensible way. Sessions, var sesh mute text, and this will just be a mutex. Sync.mutex. Obviously, I need to import sync, the package. Sync short for synchronization. There we go. So we've imported it. Now, a funny thing about this is, and this is something that Go does really interestingly, is that just by declaring a variable, it becomes instantiated at its 0 value. This works for structs as well. And so everything will be set. Every internal part will be set to its 0 value. Pointers will be set to nil and everything. So you can just create a struct by declaring it as a variable, and it will exist. So if I've got this public sesh mutex, then now in my handler function, there's only one place where I actually use the mutex. Use it. Do I touch the session anywhere before this? No. So I can do sesh mutex dot lock, and down here I can do sesh mutex dot unlock, and basically nothing has changed except no two functions can get into this part of the code at the same time. So no matter how many people are trying to play the game on the same server, it's always going to wait until there's no one else in there before you get in there. So no two people are going to handle that map badly, so that means it's safe. I think with something this simple, probably a mutex is as good as using channels or anything else. I think when stuff gets more complicated, you might start wanting to use channels, and we'll take a peek at channels next week. For now, I'm pretty sure that's everything, so let's hit Control-C and we'll run it again. Server is starting. So these games should no longer exist. So if I hit a button on this, it's going to get confused and think, oh, well, you tried to click on a thing, but it didn't work. But I happen to have that card in my new random game. So I need a new game button on this. I won't do that right now. You might not have noticed this, but of course, every time we get a new user, we create a new entry in our map. Now that's not a big problem at first, but you know, if we never empty anything that's currently in the map, even though sessions have expired, and I feel like it's worth just having a little something that runs through the map every so often and clears the map. Just says, has anything been in this map for longer than 24 hours, or however long our expire time is? If they have, we should just get rid of that cookie. Just get rid of the session, because there's no major point in doing anything with it for anybody. So, user session. I'm going to make a separate Go function that just sleeps for 12 hours. I mean, now let's make it sleep for only 1 hour. So here's our func kill cookies, and this will just keep running forever. Time.sleep. Is it time.sleep? Or is it thread.sleep? It takes a duration, that's fine, so we can just do time.hour. Time.sleep. Time.hour. So it's going to sleep 1 hour, and then at the end of an hour, it's going to grab a lock. Session sesh mutex dot lock and sesh mutex dot unlock. For k comma v colon equals range sessions, and in this we go if v dot, and it was last used, I think I called it last used, less is plus time dot hour times 24 And we're going to need to do a conversion on that. No, we're not. Dot add. If last used, dot add 20. So if we add 24 hours, and if that is still less than time dot now, then in that case session, oh, would you delete sessions k, and in here we will run go kill cookies. Fairly basic mistake. Last used undefined kill cookies, because kill cookies again, camel case. v dot last used dot add. Now reports where, so we used it after. So the basic mistake here is because actually they're not numbers, they're structs. They told a ton of stuff. You can't just do a straightforward comparison. Time dot now dot after. So after is a Boolean function. It just returns whether the outside time is after the inside time. Ooh. So this should now be able to stay running forever and not overuse all of our cookies. There's no problem with the server happening there. Control R. So we've got nothing happened so far. If I hit 8, got something happens. Click on 12, then 9, and I can do the same over here. Local host, and if I choose a card, and then another card, and then another card, and we're all happily running along here. These are different games being played, 2 separate browsers. I'm happy with that result. There are still plenty of things that need to be done to this program to make it work, but I feel like we've covered at least making cookies and keeping separate sessions workable. So, hope you've enjoyed that. Like and subscribe if you want to, and see you sometime next week.